Okay, hopefully you're enjoying your day at home. And, again, we had all that time off a couple weeks ago, so we just got to be careful with our time. And so we're going to get right into it. This is lesson 8.4, translating functions. Translating functions. And we're looking here at what's called a quadratic. Oops, sorry about that. So we're looking at what we would call a quadratic function right here, and I'll explain some more of that. But what we're going to do is learn some principles of translating. So, principles of translating. Right? And by the way, before I get going here, let me just remind you, my numbering is off on this lesson. I don't know why. And there are a couple things that are off, but that's okay. It'll all work out fine, and hopefully I'll be able to teach you all that I need to teach you. All right, the concept of translation. What is translation? Translation is the moving of a function to another location in the Cartesian plane. In other words, what you're doing is you're taking a shape, a function, could be a line, linear. It could be a V-shape, absolute value. It could be a parabola, quadratic. Could be a number of different shapes. And what we're going to do is we're going to move that shape to a different location within the Cartesian plane. And for it to be a true transformation, the object is not changed in any way. The object itself isn't changed, it's just moved. And I'll show you what I mean by that. All right, so here we've got an example of an absolute value function, and you can see it to the left. We've already done these, right? We've already done these absolute value functions. And so if you take a look on the left, it's y equals the absolute value of x. And again, we've already done these. If you go ahead and run an xy chart, and that's what I'll do right here, when x is 0, y is 0, and that's the origin right there, the vertex right there. When x is 1, the absolute value of 1 is 1. That's that point right there. When x is 2, the absolute value of 2 is 2, and that's that point right there, and so forth and so on, 3. And then you get to negatives. What's the absolute value of negative 1? 1, and that's that point right there, right? And so, and then finally, oops, let me put that back. And then when you do the absolute value of negative 2, that is 2. And so there's our V shape. So here's the point of this. I'm going to take my pen. I'm going to draw over this shape. Okay, so now we have this shape. And if we're going to translate, then technically it's to move this shape to another location. All right? So we've already learned how to translate absolute value functions. We've already learned how to translate absolute value functions. Okay? We've done this already. Here, I know I'm a little off, but let me move this to where we're seeing everything that we need to see. Okay? And that'll make some of my text a little off, but that's okay. It'll all work out in the wash. Okay? So we've got this V shape, and if you remember, the value of H tells you the horizontal movement, and the K, the vertical movement. And they also give you the value of the vertex. So according to this, the vertex of this V shape should be at coordinates 1, -2. So I'm going to take my V shape, because remember, we're translating, should be the exact same shape, and I'm going to take it to 1, -2, and let's see if indeed that is where our function ends up. Okay, so I've got an XY chart here, and let's go ahead and fill in the values of the XY chart. Now again, be careful every time I'm putting in the value for x. So when I use 0, if you look right here in this function, I want to put a 0 in for the x. Okay? So 0 minus 1 is a -1. The absolute value of -1 is 1. 1 minus 2 is a -1. Okay? So, whoops. How in the world did I get 0 there? I don't know what I'm doing here. Okay. So again, when I put 0 in for the x, right? Get -1, the absolute value of -1 is 1. 1 minus 2 is a -1. So when 0 goes in for the x, the y is -1. So I get the point 0, -1. And lo and behold, that's that point right there, 0, -1. Now we've already determined that our vertex is at 1, -2. But just to prove it to you, I have the point 1, so now I'm going to put 1 in. Again, I'm looking right here. I'm putting 1 in for the x. 1 minus 1 is 0. The absolute value of 0 is 0. And so 0 minus 2 is a -2. And sure enough, we get that point right there, 0, -2. Now if I put a 2 in for the x, 2 minus 1 is 1. The absolute value of 1 is 1. 1 minus 2 is a -1, and I get the point 2, -1. And that's that point right there. And again, you can see this is going to work when we put in 3. 3 minus 1 is 2. The absolute value of 2 is 2. 2 minus 2 is 0. We get the point 30. And again, I was a little off in my drawing, but it's that point right there. -1. Put -1 in for the x. -1 and -1 is -2. Absolute value of -2 is 2. 2 minus 2 is 0, and I get the point -1, 0, and there's that point right there. And then for the point -2, -2 and a -1 is a -3. The absolute value of -3 is 3. 3 minus 2 is 1. And so we get the point -2, 1 is that point right there. And we have translated the function. Okay? Translation. What we want to focus on this lesson is being able to read the h and the k values, because that tells us the translation. Right? That tells us the translation. So if you look on your notes, the next thing here is number 3. The amount of the translation is determined by the values of h and k. And that's what we're looking for. It's what we're after. As we've talked about before, h is the horizontal translation. That should be easy to remember, h and horizontal. And remember, horizontal, when you're going positive horizontally, that's right. When you're going negative horizontally, that's left. The K is the vertical translation. K is the vertical translation. And when you're going positive, you go up because it's positive to go up. And when you go negative, you go down because it's very negative to go down. All right? Up and down. So we're looking for H and K. H and K is the key. H and K tell us what to do. H, left to right. K, up or down. Okay. So here's our basic quadratic pattern. Notice how similar it is to the absolute value. There are just a few differences. We have a parentheses instead of absolute value symbols, and we have a squared, a quantity squared. Those are the only differences. Other than that, it would look just like absolute value. H is still H and K is still K. And remember, just like absolute value, we read the H after a negative sign, X minus, and then whatever the H is. Okay, so let's take a look. A, the coordinates of the vertex are HK. So just like our absolute value, the vertex for HK, here again, the coordinates are HK, and those coordinates describe the translation. So in this next section, we're going to go ahead and name the vertex and describe the translation. So let me go higher on the page here. All right, so we're looking at our pattern. And so on the first one, hopefully you would read the value of H is 2. What would be the value of K? Again, look, you're at home and you're watching, but you still need to think, all right? You need to be thinking all the way through. And when I say what's the value of K, you're thinking of, and I hope you're thinking 0. You know, we could have written this function plus 0. We don't bother to write plus zeros. We understand that the vertex is 0. All right, so the vertex is at 2, 0. So this translation, the 2, remember the 2 is the horizontal translation and it's positive. So this is translated 2 to the right and nothing up or down. So just 2 right. Second is similar. Again, we notice that the H is a 9. The k again is a 0, so we're translating, the vertex is at 9, 0, and so we are 9 to the right. Okay, pretty simplistic. We're just reading h and k. Now, be careful with 3. We went through these with absolute value. And again, we have to understand how we read the value of h. The value of h is read after a negative sign. We don't have a negative sign. So I'm going to rewrite this with a negative there. Now, the way you come up with a positive 3 is if you have a negative 3. Now, do you see the value of h? H is a negative 3. So this is negative 3. Again, our k is 0 in all these first few examples. And therefore, now we are translated to the left 3. Left 3 or 3 left. Okay? You're reading h and k. So you're learning this pattern. That's what you got to do here. You got to learn the pattern. So again, look now, we've done this with absolute value. See, here's the absolute value. H and K, again, telling us how this thing is translated. And now we're doing it for what are called quadratics. All right, so here's our pattern again. Now let's deal with the vertical shift. All right. So you can see on the left here, here's our basic quadratic. Now normally this would be written y equals x squared. There's no h value, or h is 0, and the k is 0. This shape is called a parabola, and notice h and k are 0, 0, and the vertex right here is at 0, 0. Now if you look to the right, what has happened to the vertex? Well, if I read the coordinates of the vertex, 1, 2, the coordinates of this vertex are 2, negative 1, right? 2 to the right and 1 down from the origin. And notice the value of h is 2, and the value of k is negative 1. This is translated 2 to the right and 1 down. And our shape didn't change. It was just translated or moved to the right and 1 down. So, name the vertex and describe the translation. Okay. In this first example, you don't see any h value, right? Technically, you wouldn't have the parentheses there. I'm just trying to get you to understand that this is exactly the same as x minus 0, right? And so we know h is 0, we know k is 2, and therefore the vertex is 0, 2. And how is this translated? Again, think in your mind. Be saying something, and hopefully you're saying this is translated 2 up, right? Or up 2, I don't care your order, right? The second one, what's the value of h? Again, it's 0. What's the value of k? Negative 7. So what's our vertex? 0, negative 7. No translation left or right. But what about up, down? This one is down 7 or 7 down. All right. Okay, number 4. What crazy numbers. I tell you, this lesson is really funny. 1, 2, 3, 4. All right. It's going to be all throughout, and even the letters are kind of goofy on this one, but oh well. That's the way it goes. All right. Number 3, the h is 1. Hopefully you concur. And the k is negative 2. So let's go ahead and fill those in for the vertex, 1, negative 2. All right, so now we've got to deal with the horizontal translation. We are 1 to the right, and we are what? 2 down. 1 to the right and 2 down. All right, go ahead and do number 4. I'm going to pause, or you should pause the video and go ahead and do number 4 and then restart it. All right, pause the video and do number 4. All right, be careful here. And again, hopefully you're understanding that you can't read h except if there's a negative in front. So again, this is technically x minus a minus 3 plus 8. So what is our vertex? Negative 3, 8. And what is our translation? 3 left and 8 up. 3 left and 8 up. Okay? translations. Now, to write the equation, use the pattern to fill in h and k. To write the equation, come on, Windows, use the pattern. All right, I don't know what just happened there. Everything's off. Let me see if I can get it back. Okay, we'll get there. Sorry about that. To write the equation, use the pattern to fill in h and k. All right, so here's what we're given the first time. Write the equation of the quadratic. So it had to tell us that, right? If it is translated 3 right and 4 down. All right, 3 right is a positive 3, right? And 4 down is a negative 4. Now we take our pattern, and where h is, we put in h, which is a 3. And where k is, we put in k, which is a negative 4. And that's it. We've written the equation of the quadratic that's translated 3 right and 4 down. In the second question, write the equation of the quadratic if the vertex is 4, 1. 4, 1. Remember, the 4 is the h, and the 1 is the k. So now we know h is 4 and k is 1. 4 is 4 right, right? And 1 is 1 up. But again, all we need is h and k, so we're going off of y equals x minus h, quantity squared plus k. And you should write that every time you got to do a problem like this tonight for homework, because you need to start learning the pattern. Again, it's not hard, it's very similar absolute value, but you need to learn your pattern. So now we'll just go in and fill in our h and k. H was a 4, and our k was a positive 1. And we've written the equation of the quadratic. All right, number 3, same situation, only now they give us a vertex of 0, 2, so we know our h is 0, we know our k is 2. Again, our pattern, y equals the quantity, x minus h, quantity squared plus k. With a 0, we really wouldn't include the 0. We would just do x squared. Okay, x minus 0 is x, and you get x squared. And then we do the plus k, which is a positive 2. Now, be careful. I didn't give you one with a negative h. So if that's the case, you got to be careful and make sure you do negative your negative. I talked about that already. You're going to have to apply that. Okay? All right. There's also a cubic pattern. Notice how similar the cubic pattern is to the quadratic pattern. There's only one difference. The quantity is cubed instead of squared. See, math is so orderly. It's the beauty of math. There's so much order to it, and you learn patterns, and these patterns apply in many different areas. So we've now gone from quadratic to a cubic, and the only difference is that the quantity is cubed. We still have the x minus h quantity cubed plus k. And guess what? H and k are the translation of the cubic. Now, the vertex, quote unquote, is really the point that is a center point of the cubic, because cubics are different. Okay, so the coordinates of the point of, and here's a term you need to learn, inflection. Inflection. What does that mean? All right, take a look at the first one right here. Look at this example right here. There's the point of inflection right there in the center, right, in blue. You take a look at this part up there and this part down there, and they are like mirror images of each other and reflected down. So we call it the point of inflection. Point of inflection. All right? And again, they describe the translation. So in the first example, we have the base model again. This is simply the base model. It's not translated anything left or right, and it's not translated anything up or down. So technically, you'd see it listed just like this. Y equals x cubed, right? The h is 0, the k is 0. We don't usually write the zeros. Now, in the second situation, let's go right to the graph. Let's figure out the coordinates of the point of inflection. Coordinates are -2, -1, right? Those are the coordinates of the point of inflection right here, right, in blue. So now let's go back and read HK. And again, remember, we read the value of H after a negative sign. So H must have been -2 if this is written +2. So what's the value of H? -2. This is translated 2 to the left. And what's the value of K? -1, 1 down. And sure enough, there's the cubic translated 2 to the left and 1 down. Nice and orderly. Okay, so let's go through and figure out some points of inflection and how the cube is translated. All right, first example. Can you write the coordinates of the point of inflection? Coordinates of the point of inflection. All right, well, hopefully you think the H coordinate is 2 and the K coordinate is 0. Therefore, what is the translation? 2 to the right. This is translated 2 to the right. Okay, pretty simplistic. All right, again, if I were to rewrite this, then I would rewrite x minus 2 quantity squared cubed plus 0. Now, the second one says point of inflection. And so this is supposed to be a cubed here. So let's change that to cubed, because you would have a vertex if it was a square. You have points of inflection for cubes. All right, so that's supposed to be cubed. All right, so you look at it. What's the value of H? And I hope you're thinking 0, right? Because nothing's shown. What's the value of K? -11. So how is this thing translated? This thing is translated down 11, right? Or 11 down. Third example. Again, pause it if you need time to think, but you need to be thinking, what are the coordinates of the point of inflection? And I hope you think the H value is -1 and the K value is 5. So how is this translated? 1 left, 5 up. 1 left and 5 up. Let me throw one more in here before we leave this subject. Hey, beware of something like this. What if they said y minus 3 equals the quantity x, let's go minus 5/2 quantity cubed, and let's go with plus 4. Okay, H is going to be what? And hopefully you'll say 5/2. Okay, so 2.5. That's not a problem. It could even be a decimal. It could be a root. It could be a square root of 7. It could be anything. That's okay. It's the value of H. H is 2.5 to the right. But be careful with K. You see how it's not y equal right now? Hey, we got to move this -3 to the other side. How would we do that? By adding +3 to both sides, right? I'm going to add a +3 to the left. I'm going to add a +3 to the right. And when I do that, the total on the right is going to be a 7. So K is 7. So how is this translated? 5.5. 5/2 or 2.5 to the right and up 7. Or that tasty beverage, 7 up. All right, what if they say write the equation of the cubic if the point of inflection is 5, 9/2? You need to start with your pattern. All right, y equals the quantity x minus, and I'm going to fill in the h in a minute, quantity cubed. And then we have h plus k, right? Start with your pattern. Again tonight, start with your pattern, start with your pattern, start with your pattern. All right, from there, they gave us the point of inflection, so they gave us h. They gave us the point of inflection, so they gave us k. Hey, let's do one a little bit more tricky. Let's change this 5 to -5, just so I practice one of those. Let's suppose it was -5, 9/2. Okay, so now when we fill in x minus, I'm going to use my red here, -5, right? Quantity cubed, just putting it in the pattern, plus 9/2. All right, who cares if that's a fraction? No big deal. All right, we should finally finish up with taking care of minus a minus. So we end up y equals x plus 5 quantity cubed plus 9/2. And there we've written the equation of the cubit. Hey, translations, they're not hard. What is translation? Moving a function to another location in the Cartesian plane. The object isn't changed technically in any way if it's a true transformation. Okay? We've done absolute value before. There's the absolute value pattern. Notice how similar it is to the quadratic pattern. Again, what are the differences? Instead of absolute value, we have parentheses, and then the quantity is squared. That makes it quadratic. The fact that we have a variable squared. And then we also learned the pattern for a cubic. And what was the pattern for a cubic? Very similar to a quadratic, only now the quantity is cubed. Do cubics have a vertex? No, they have a point of inflection, right? A point in which the image is reversed and mirrored, right? So a point of a middle point, if you want to think of it that way, a point of inflection. So those are the three patterns we're dealing with today. We have to know how to figure out the vertex or point of inflection coordinates. We have to figure out how it's translated, left, right, up, or down. And then we also have to be able to write the equation of the absolute value, of the quadratic, or of the cubic using the pattern. Okay, hopefully you're going to enjoy your day off today. But again, we've got to be busy in it. Hopefully you did well with your scientific notation homework from Friday night. Now this is the homework leading into tomorrow's class. And remember, tomorrow we will have a quiz. It's Wednesday. We'll have a quiz over some rules. You'll have the rule section. Some of you are struggling some on the rules. Hope you've gotten those figured out in these days off. And then scientific notation. Be careful there. You'll have to multiply and divide with scientific notation, add and subtract as well. And then you'll have to be able to use these patterns in absolute value, in quadratics, and in cubics. Okay, enjoy your day.